For as long as we've existed, standing still has never been an option. It's part of who we are, the need to move, to search, to see what lies beyond the next horizon. From our ancestors crossing continents on foot to sailors who vanished beyond the edge of known maps, that instinct has never faded. Over time, we replaced sails with rockets and oceans with the void of space. We reached the South Pole, dove to the bottom of the sea, and stepped onto the moon. Yet still, we look further. Because as far as we've gone, there's one journey that defines everything about us: the path from Earth to Mars. NASA says that this dream isn't a fantasy anymore. They already have a plan, a blueprint to turn that red in the night sky into humanity's next home. But before we can make that leap across the void, we must first learn to survive in the emptiness closer to home. Before we can walk on Mars, we have to master living somewhere else, the moon. It might look close in the sky, but surviving there is one of the hardest challenges humanity has ever faced. The moon has no air, no protection, and no mercy. But it also has something that Earth doesn't: freedom from gravity. Launching from Earth means fighting through a dense atmosphere that limits how much we can send to space. The moon, however, offers a clean slate, a low-gravity world that could become the perfect spaceport for the rest of the solar system. That's why NASA's Artemis program is more than a return, it's a test of survival. Artemis missions will teach us how to extract oxygen and water from lunar rocks, how to build infrastructure using what's already there, and how to live without constant resupply from Earth. If we can thrive on the moon, we'll prove we can do the same anywhere, even on Mars. But while humans prepare for life off-world, machines have already begun carving out the path ahead. Before a single human foot touches Martian soil, robots will have already set the stage. For years, NASA's rovers, from Spirit and Opportunity to Curiosity and Perseverance, have rolled across the planet, gathering secrets from a frozen desert billions of years old. But in recent years, something revolutionary happened. We learned how to fly on Mars. The tiny Ingenuity drone, originally just an experiment, became a trailblazer, proving that powered flight is possible on another world. That simple success changed everything. It means future missions can explore faster, farther, and smarter. Now, NASA plans to deploy fleets of drones to scout the terrain, locate resources, and even collect samples for future astronauts. And orbiting above them all, an autonomous space station will one day circle Mars, acting as a communication hub and rest stop between worlds. The robots aren't just our tools, they're the vanguard, paving the way for the first humans who will follow. And once that foundation is laid, the true mission can begin. No one will step onto Mars empty-handed. Before the crew even leaves the moon, everything they'll need to live and return must already be waiting for them: food, oxygen, equipment, and the fuel for their ride home. NASA's plan starts with Artemis 10 and 11, each delivering massive payloads into lunar orbit. These Mars cargo stages will eventually make the long journey to the Red Planet, carrying essential supplies and a lander that weighs more than 25 tons. Artemis 12 will take the next leap, sending the Mars 1 human lander and the interplanetary habitat to the Lunar Gateway, a new space station orbiting the moon. This will be the launch point for the first human mission to Mars. Every step is calculated, every kilogram accounted for, because once the astronauts leave the gateway, there's no backup, no rescue, and no margin for error. It's the most complex space relay ever attempted, but it's the only way to make Mars possible. When the time finally comes, the crew will leave the safety of the moon and begin a journey that no human has ever made before. 4 astronauts will travel in a transit habitat, a ship powered by a hybrid of chemical and electric propulsion. For months, they'll drift between worlds in silence, surrounded only by darkness and the hum of machinery. 2 of them will stay in orbit around Mars, managing the systems and monitoring communications. The other 2 will descend to the surface in a lander that doubles as both their home and their vehicle. For 30 days, these 2 explorers will live on an alien planet, walking, working, and dreaming beneath a salmon-colored sky. The gravity will be weak, the danger constant, but the view will be unforgettable. This is more than exploration. It's proof that the human spirit can endure isolation, fear, and distance beyond imagination. Yet, Even after all of this preparation, one of the hardest parts is still ahead: the landing. Landing on Mars is like threading a needle in a hurricane. The atmosphere is thin enough that parachutes don't work properly, yet thick enough to burn you up if you come in too fast. NASA learned this the hard way with the Perseverance rover, which survived a descent that looked more like science fiction than reality. The capsule had to endure blazing heat, deploy a massive parachute, then switch to rocket thrusters mid-fall. Finally, it hung from a sky crane, literally a hovering jetpack, that lowered the rover to the ground on cables before flying off to crash a safe distance away. Now imagine doing all of that with humans on board. The crew's lives will depend on systems that have to function perfectly in a place where nothing ever goes as planned. The descent will be violent, chaotic, and breathtaking, a high-speed ballet between gravity and technology. But when the dust settles, two human beings will stand on Mars. And in that moment, everything will change. NASA has outlined 2 possible missions to Mars, and both come with unimaginable challenges. The short-stay mission will use a gravity assist from Venus to sling the spacecraft toward Mars. It'll take about 217 days to get there, followed by just 30 days on the surface, then a brutal 403-day trip back to Earth. That's nearly 2 years away from home, most of it in deep space. The long-stay version flips the equation: 210 days to Mars, but 496 days living on the planet itself. Almost a year and a half under an alien sky, waiting for the perfect orbital window to come home. The choice is a haunting one: spend longer in the emptiness of space, or risk your life on a hostile world. Both paths demand courage beyond reason. And for the people who take this journey, time will stop meaning what it once did. Every day will be a reminder that humanity has truly left Earth behind. But soon, technology may offer a faster way. Right now, the biggest problem with Mars missions is time. The longer astronauts spend traveling, the greater their exposure to radiation, isolation, and the limits of human endurance. That's why NASA and DARPA have joined forces on a radical solution: a nuclear thermal rocket called Draco. This isn't science fiction, it's real technology being built today. Compared to chemical rockets, Draco could be up to 5 times more efficient, cutting travel time from 8 months to as little as 45 days. Imagine that, a trip to another planet in the time it takes to cross the ocean by ship. Nuclear propulsion could completely redefine what's possible in space exploration. It means faster missions, lighter payloads, and a future where humans move between planets like early explorers once sailed between continents. It's bold, dangerous, and revolutionary. Exactly the kind of leap forward that defines humanity's story. And when Draco ignites, the countdown to Mars will truly begin. Human beings have never been good at staying where we're told. Every era has had its impossible frontier, and every time, someone has crossed it. The journey to Mars isn't just a race between nations or an engineering challenge. It's a reflection of who we are. Yes, the timeline may slip. The budgets will rise. The risks will remain. But none of that matters in the long run. What matters is that we keep going. Because deep down, every one of us feels it, that quiet pull toward the unknown. The moon will teach us how to survive. Mars will teach us what it truly means to live beyond Earth. One day, future generations will look up at the night sky and see our lights shining on another